Hello, everyone, and a very warm welcome to Kognito Key. I am absolutely thrilled to have you joining me today. Have you ever stopped to wonder how your phone, your laptop, and your smart TV all manage to communicate over your home network without constantly crashing into each other? Well, it's actually a fascinating process. And in today's explainer, we're going to unpack the brilliant protocol that makes the whole shebang possible. It's called CSMA, and it basically acts as the ultimate network traffic cop.
Now, to truly appreciate how smart our networks are today, we kind of have to understand the problem first. Imagine you're in a crowded, rowdy, Wild West saloon. What happens when absolutely every single person in that room tries to shout their order to the bartender at the exact same time?
Right. It's absolute chaos. Nobody is understood and the message is completely lost. In the early days of networking, our devices basically acted exactly like those cowboys. Multiple stations trying to transmit data over a shared channel at the same time, it resulted in guaranteed collisions.
Okay, let's dive into this and look at the earliest attempts to fix this chaos. The first protocol was pure ALOHA, and the rule here was super simple. Transmit whenever you want. But, as you can probably guess, because nobody was paying attention to anyone else, partial and complete collisions of data packets were pretty much guaranteed. It led to massive data loss. So, they tried to improve it with slotted ALOHA, which divided the channel into strict time slots. It was slightly better, for sure, and it stopped partial collisions, but if two devices picked the exact same time slot, boom, a complete collision still occurred. So we desperately needed a much better, much smarter system.
And that is exactly where CSMA comes to the rescue. CSMA stands for Carrier Sense Multiple Access. It introduced a revolutionary, yet incredibly simple concept to networking. The golden rule is sense before transmit. Or to put it in everyday human terms, listen before you speak. Instead of just blindly shouting into the network, each station is now required to politely check the shared channel first, just to see if anyone else is already talking.
It really is just like a traffic light system for your data. When a device senses the carrier, or the channel, it's looking for one of two states. If it detects a busy carrier, it means another device is already transmitting. There's an ongoing conversation, so our device knows it has to wait at the red light. But if it detects an idle carrier, a green light, it means the room is quiet, the channel is free, and the device knows it is perfectly safe to start transmitting its data packets. Sounds pretty foolproof, doesn't it?
But let me ask you all a question. If every node is so polite and they all strictly listen before they speak, why isn't our network efficiency, our throughput, a perfect 100%? Why on earth do data collisions still occasionally happen in a CSMA network?
Well, the sneaky culprit behind these remaining collisions is something called propagation delay. And this is an absolutely crucial concept. Propagation delay is simply the physical time it takes for a transmitted signal to travel from one node through the cable or the air to reach the other nodes in the network. Imagine you're in a massive echoing concert hall. You listen, the room seems totally quiet, so you start to speak. But actually, someone on the absolute far side of the hall had started speaking a split second before you did. Because of the physical distance, the sound wave of their voice literally just hadn't reached your ears yet. You thought it was clear, but it wasn't. The exact same physical limitation applies to network signals, and that tiny delay is what causes those rare collisions.
So, to keep our networks running smoothly, engineers use this crucial formula. We represent the efficiency factor as A, which equals the propagation delay, divided by the packet transmission time. The key takeaway here, the real so what of this equation, is not for CSMA to work at its absolute best. The propagation delay must be kept as incredibly small as possible. When the delay is tiny, nodes instantly hear when another transmission starts, which means they won't accidentally start talking over each other.
Now that we know the basic rule of listening first, let's take a look at the three personalities of CSMA. You can think of these different network modes as three very different types of people trying to get a word in during a busy board meeting.
And this brilliantly illustrates exactly how our modern networks function behind the scenes. Let's look at step one, the one persistent personality. This is the impatient one. If the channel is busy, this node continuously, obsessively checks the channel over and over. The exact millisecond the channel is free, bam, it transmits. This is heavily used in traditional Ethernet. Next up, step two, is the non-persistent personality. Now this one is highly patient. If the channel is busy, it doesn't constantly check. Instead, it backs off, waits for a completely random period of time, and only then checks again. It's much more relaxed and really reduces the chance of multiple people jumping in at the exact same time. Finally, step three is P-persistent. This is the highly calculated, mathematically cautious personality. and it's heavily used in our modern Wi-Fi networks. It constantly senses the channel, but when it finds it free, it doesn't just automatically transmit. It transmits with a specific probability, p. If it decides not to transmit, it waits for the next time slot. It's a fantastic blend of being eager, but mathematically calculated to avoid data crashes in wireless airwaves.
So, the next time you're effortlessly streaming a movie or sending a massive file, take a brief moment to appreciate the highly structured, polite conversation happening right under your nose. It's all thanks to the brilliant logic of CSMA. Thank you so much for joining me today on Kognito Key. I really hope this explainer made the complex world of network protocols crystal clear for you. Keep learning, stay curious, and ask yourself, how polite is your network conversation today? And hey, before you go, please don't forget to subscribe to Kognito Key and like and share this video. See you next time.